Hi, Sean.
Hi, Marianne.
Hi, Sean.
And we're done saying hi. Okay. So what we are going to focus on are these first two, lines and planes in space. Okay? But we're not going to worry about distances. We're just going to kind of brush the top with lines and planes. Okay. So we have studied lines in 2 dimensions. Y equals mx plus b. We have some slope. Okay. Now in 3 space, we can't really describe one slope. Okay. But a line we can say is determined by a vector. Okay, or a direction vector. Vectors we think of in standard form, which means they're coming from the origin. Not all of our lines are going to be coming from the origin, so we're going to call it a direction vector. Okay, so instead of slope, we have a direction vector, which is kind of describing 3-dimensional slope if you think about it, right? Okay. So, to determine an equation passing through a point in the direction of this vector, okay, we're going to use our knowledge of parallel vectors and scalar multiples, right? If 2 vectors are parallel, they are scalar multiples of each other, okay? So if we're going to go through the point P and a point Q, then the line has to be a scalar multiple of ABC. Okay, you don't need to write anything down yet. All right? You aren't writing anything down. Oh, that appeared. Okay, so the vector PQ is a scalar multiple of ABC, where T, any real number, is a scalar. Or we can think about it as, okay, remember I defined P as x naught, y naught, z naught. So x minus x naught, y minus y naught, z minus z naught should be the same as AT, BT, CT. Right? Okay, don't write anything down yet.
Okay.
So, I'm gonna write them down. Nice. Okay. So if we take this, we set each component equal to each other, we have this. Okay? Here we have a set of parametric equations that describe our line. If we solve for t, we have these. Parametric equations, symmetric equations.
Those are circles in red. It should be like that.
Yes. My rule for calculus AB today was if I wrote in red, you should write it down.
Is that
Parametric equations of the line.
I didn't know it was supposed to be so windy today.
No.
I see people's hair blowing.
Oh man, there's a breeze in here even.
Someday I'm going to come back and just listen to these videos.
And then you'll miss us so much.
I will. I'll wonder how I ever survived.
Us and our horrible, horrible jokes.
Yeah, you can punish us. Punish.
Common. Are you
Oh,
friends with
God.
Brown Hanson? to be in German again.
Okay.
But she's not your German.
I
God, you get it.
I don't get it.
Nope. Okay.
I don't get it. I spent half the class feeling out.
Hey, guess what? This is the same thing, so don't worry.
Oh no, oh no.
This is the same thing, so I went ahead a slide, but I don't need
Nothing
to
changed.
go back. Yeah.
That was really good.
Oh, but the circles are gone. You should get to know crashing.
So should we
And then ask her about, like, it's so red.
They're married.
No,
Yeah.
it's not surprising.
Are we ready?
I don't know.
Okay. Find the parametric equation and symmetric equations of the line passing through the point 2, 3, -4 and parallel to the vector -1, 2, 5. So essentially what is happening is we have a point and we have our slope, right? Our direction vector is essentially our slope, our three-dimensional slope. Okay? So what are we going to do with that?
Well, the point is gonna be our set of knots,
Yep.
you know, not much. And then the letters are gonna be the parallel vector,
Okay.
and then t is a variable.
So x equals 2 plus -1 times t. Y equals 3 plus 2 times t. And z equals -4 plus 5 times t. You wanted me to teach this first, is that what you said?
No, I asked, why don't they teach this first?
Oh.
Because then you would not use stuff.
Because we have to know, like, no, not
You
that
did.
stuff,
Multiplication.
Yeah,
Okay, so our symmetric equations is basically just solving for t. X minus 2 over -1, y minus 3 over 2, z plus 4 over 5. If you think about it, x minus the x value over the vector component, y minus the y value over the vector component, z minus the z value over the vector component.
And so you could theoretically define this equation in terms of z.
if you multiply by 5 and then subtract 4.
But you realize that there's 3 of them.
Yeah, there's 3 equations though, so.
Yeah, because my calculator takes three-dimensional equations in terms of z.
Right. Well, you can put it in parametric mode, maybe.
Graphs. There were two things.
So,
Well, or what you could do, let's see if we can figure this out.
You could use the parametric form and rewrite it that way by solving.
Right, you basically, you would take this equation and solve for z, and then take this equation and solve for y to plug it into the y.
You should solve for z.
You need all 3 letters, though. We're gonna have to think about that.
yeah, so what do you input into the symmetric equations? Do you?
Well, I guess I could do parametric.
This is like t equals.
Right, so then you plug it in t and you have to solve. They'd all have to equal t, whatever t is.
Yeah.
Okay.
Yeah, give me z.
So that's what, like, this is probably more efficient to work with, like, if you want to plot some points, t equals 1, find a point, t equals 2, find a point, t equals 3, find a point. Really, you only need 2 points and you know what your line is, right? Okay? What if you only know 2 points?
And the vector is E vector.
Could we find the direction vector? Yes. Now, does it matter in which order we find the direction vector?
No.
No. Okay? Because a vector and its opposite are still parallel. Okay? So it's not going to matter. When we have 2 points and we're writing an equation of a line, there could be more than one set of parametric equations to describe it to get you the same thing. One thing that could be different is which vector you choose, whether you choose one direction or the opposite. What would you like to do?
Right minus left.
Okay. Terminal minus initial?
Yeah.
Excellent. So our direction vector would be 3 minus 1, negative 2 minus 2, and 5 minus negative 2. Okay? Then we would have to do what? Oh, we have 2 points.
Pick one. It doesn't matter.
We can pick one. Okay.
One
So
negative.
so we could write 1 equals x equals 1 plus 2t, y equals 2 minus 4t, z equals negative 2 plus 7t. If you wrote that, like if Jared wrote this and Graham wrote x equals 3 plus 2t, y equals negative 2 minus 4t, z equals 5 plus 7t, they would be describing the same line. They would just have to choose different t values to get the same coordinates. Does that make sense? Okay. Our symmetric equations, x minus 1 over 2 equals y minus 2 over negative 4 equals z plus 2 over 7, which would be the same thing as x minus 3 over 2, y plus 2 over negative 4, z minus 5 over 7. Okay, so there would be 2 different ways to describe that line in a set of parametric equations. Alright, are you ready for some planes? Andrew, are you okay?
Sorry, I just noticed he's like, see through it.
Miss Holman?
Yeah.
For the symmetric equations,
Mm-hmm.
if you plug in like an x value or a y value or a z value, they're all going to be equal, and so that number is going to be your t value. Okay.
You plug it for the
For a point on the line.
for symmetric equation, that one's more for like you plug in a t value in all your x, y's,
You plug in a t value.
yeah.
And then there's like,
There's t equals all.
Okay.
Yeah.
Okay. Okay. So we've talked about planes. We've talked about the xy plane. We've talked about the yz plane. We've talked about the xz plane. That's really about it, right? So if you see my picture, I have a point P and a vector n. And what's true about vector n?
it's orthogonal.
It's orthogonal. We also say normal, right? In calculus.
Oh.
Okay.
Yeah.
To the highlighted plane. What's the point?
I didn't know if we were just, it's orthogonal and now it's normal, but yeah.
Well, it's more
Orthogonal.
of a physics thing.
Okay. So for any point Q in the plane, so 2 vectors are orthogonal, right?
Okay.
A plane and a vector we would describe as orthogonal.
Yeah.
Okay. So, but if we drew vector PQ in the plane, and we have vector n,
They're orthogonal.
they need to be orthogonal,
Okay.
right? So don't write anything down yet. I use the word perpendicular, sorry. So since those two are orthogonal, their dot product has to be 0, right?
Yeah.
Technically, PN is the cross product of PQ.
Okay, so is everyone okay with what I wrote? So here's vector n, vector PQ. Their dot product is 0, right? The last equation, so this right here is the equation for our plane.
For these two.
Yeah, write these two. So here's the standard equation of our plane. Here's the general form, which means we multiply everything out.
Why did they choose the word PN?
I don't. There's like a log or something. You see it floating there?
What?
Whoa.
On the screen.
It's not on the screen.
It's
I just
there.
looked it.
Are you sure?
No,
It's not on the screen.
Difference is math.
Go up there and look for it.
It's not on the screen.
It's on the projector.
Oh yeah, he's up there playing around. I see him.
It's the only way it could have descended so
Quick, somebody hit it with the chair. Throw a calculator at it.
So I'm not lying here. I was sitting here eating lunch yesterday, and this teeny tiny spider just dropped like right here, like on his web. And it was like one of those jumping spiders where when you go to try to smash it, like he jumps.
Why'd you try to smash it?
I was eating my lunch.
Spiders are friends. So, wait.
No.
Fish are friends.
They have 2 minutes left in your lunch.
No,
What happened to your lunch when you
spider
tried to
bro.
smash it?
I eat all the bugs.
I'll take
I-
spiders over.
If you're holding your lunch still out there.
My lunch was like on the table and I was eating with a fork.
Oh.
Okay, are we ready for an example? Do we have this written down now? That would just be the constant, like when we multiply these numbers and add them together, we're gonna get a constant added at the end, and that would be that number. Great question. Okay, so we have the normal vector 3, 1, negative 2, containing the point 2, 3, negative 1. Write an equation to describe the plane in standard form and general form. So standard form, we are simply going to say 3 times x minus 2 plus 1 times y minus 3, wouldn't necessarily need the 1, minus 2 times z minus negative 1 equals 0. It's freaking me out, I know it's a typo. General form.
Yeah, that's way down.
What?
It's like great.
Oh, see?
Where?
Right there. Right there.
Is it like floating?
Yes, get it. Like,
Throw a chair.
it's gonna jump.
Oh, I see it.
You're just gonna like get it, like
Oh, that's the fun thing to do.
Aw.
Like, I'll smash it if it's on the ground, but it's like floating in the air.
Floating by you.
You know, with all this spider stuff with us happening, Marianne, you should probably.
I think you're safe now.
There's probably a giant spider about to bite you.
No, 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 no,
You're-
spider's friend.
Please.
So,
It's still floating.
thank you.
It's probably on your clothes.
Yeah,
Yeah, we can't see because we're wearing your flag.
It'd be like on the
Minus 11.
It's floating right there.
Okay, so this is standard form, general form.
But what if we're given 2 vectors? Or I mean 2 points. 3 points.
Now we need cross.
We wouldn't need 3 points.
2
If you
points.
get 3 points, you just do a cross product.
With 2 points, you just need to find one who's that product.
You would need 3 points.
Yeah,
Sorry.
okay. Just
Says
two vectors.
2 points create a line. 2 points define a line. 3 points define a plane.
Right.
You could do
3
cross
points,
academy,
you can
find
have
some
2
chick
vectors.
that I like.
Okay, so you guys, your minds are already ahead of me here. Let's
It was number 8.
Yep.
number 8.
Yep.
Yeah. It's like I was preparing you for something.
Wait, are you supposed to prepare us then quizzes?
Are you telling me that you didn't know how to answer that question with the knowledge that I had given you?
I don't know. It's just what you said. Right there. Can't go for it.
Did you give us 3 vectors?
No. I was very confused. No, wait.
Aha, 3 points.
Yeah, it was something like that.
I'm
Something stupid like
confused about
that.
how you were confused.
Okay. Anyway, so if we have 3 points in a plane and we want the equation of a line, then we want to create 2 vectors that lie in the plane, and with 2 vectors we can find their cross product, and that cross product is a vector perpendicular to the plane, which is what we want.
Okay, so that's the answer.
So once we find the normal.
Sean's in.
Oh,
He's not taking until Monday.
The next quiz, the
Oh.
one next week.
it wasn't 8, it was 7.
Are you sure it wasn't?
Are you guys talking about number 2?
Okay,
I think it.
are you ready? What do we want to make a vector from?
A and B.
Middle minus.
Okay, so let's do these 2. So that vector would be 3, -2, 4. 4? Okay, and then from those 2, does it matter?
No.
Not particularly. They're all on the same plane.
1, -3, 6.
So, you know what that was.
First recovery of both of yours.
Okay, so cross product. Let's see if we can do a better job of multiplying and combining like terms here.
$9K.
Yeah.
Yeah.
See how easy it is to make them.
I checked on my calculator for mine, not gonna lie.
Negative
I
2K.
should have them.
Negative 12I, in other words, I for it. 18K. Literally, can't I for it.
Okay? So how many I's?
Negative 0.
I read my T as 9. I'm
Okay.
sorry.
How many J's?
Negative 14.
14.
K's?
7.
Now, it is possible, depending on how you chose your vectors, you could have gotten positive 14j plus 7k. Still perpendicular to a plane, just in the opposite direction. Okay, so now we can take that with any of those points. Okay, so 0 times x minus 1 minus 14 times y minus 2 minus 7 times z plus 1 equals 0. Okay, now in standard form they're going to look different, right? General form we get the same equation. So what I'd like you to do is I'd like you to write it using a different coordinate. I'm going to multiply this one out, you multiply a different one out, and let's make sure we get the same thing.
Like find different vectors?
Oh, by the way, just.
Like, use this standard form with one of these two coordinates and multiply it out. Yeah.
I think I figured out my calculator. For parametrics, you have to use parametrics to find a line. Use equations like this in terms of z to find planes and three-dimensional curves.
Okay. There.
Which is weird.
Yeah, it'll work.
Yeah.
Well, I was trying to do it a little bit. So you do 4, 0, 3, 7. Oh, I see what you did there. Oh, okay.
Okay. Did you get 21 as your D value using a different point? Okay. Now notice what I did here. Since all of these, what do I say? They all have a common factor. We can divide both sides by that common factor. Since the other side is 0.
You could divide everything by 0.
No, that's not what I said. I just divided by -7. But thank you for putting words into my mouth. Just for fun, what time is it? Oh, 3:20. Let's just talk about how you would plot these vectors. Or not vectors, planes. Okay? So basically what you're going to want to do is find the intercepts. So like on this plane, sorry, I like doing the work on here as opposed to them doing it.
For your other BC ones.
Okay. It is all grappled. So, I hope not. It's not. I'm not afraid of spiders, but when they're in midair, it just creeps me out. Like I will step on them if they're on the ground, but midair.
You're still kind of afraid of them. Carry them around. Spiders keep biting people out.
Anyway, x plus 3y plus 4z minus 12 equals 0. If we plug 0 in for y and z, we get our x-intercept. So we can plot that x-intercept here. If we plug 0 in for x and z, we get our y-intercept of 4. We can plot that coordinate. If we plug 0 in for x and y, we have our z-intercept, 3. When we create that triangle, we can imagine that plane going through space. I mean, it's the best we can do. Okay. Is there anything else?
My brain keeps trying to stick the plane in like 60 different places.
Actually, we do have one more thing. Okay. Now we're going to talk about the intersection of planes real quick.
The intersection of two planes.
intersection of two planes is a what?
Third plane.
Two planes intersect at a line.
At a line. Two planes intersect at a line. Okay? So how do we find the equation of that line?
Set them equal to each
And what
We're not going to set them equal to each other.
Just add them. Find common points.
I mean, kind of.
So, never mind.
We're going to eliminate a variable
Yeah, that's what I was trying to say.
so that we can write it in terms of another, so that we can write our parametric equation.
Yeah, I was trying to get rid of just have the word. Say.
The thing.
Yeah.
I didn't even notice anybody's done anyways.
Okay, so if we multiply our first equation by -1, we can add the two equations together and the x goes away. What?
The y's would have gone away anyway.
Okay.
We wanted to eliminate the x's.
It's not going to matter. Okay. So we eliminate x, and now we have an equation where we can solve for a variable. Then I can take that variable and plug it back in. Okay. And so now we have these two equations in terms of z.
Yes. Okay.
Okay, so as long as we can get two equations in terms of the third variable, so two variables in terms of the third, then we can write a set of parametric equations. So here I have y equals -1/3 z. I plug it into any one of our equations, so I can write x equals -3z. And then if we define t to be z, we can write our parametric equations.
That makes some sense. There you go. Makes sense.
So if you choose a different variable, your set of parametric equations would look different. If x equals t, then y and z would look different, but when I start plugging in values for t, we get the same points on that line. Happy to do it.
I think I'm good.
Okay, so let's start a sign-up sheet up here. If you would like to bring something for Pi Day, sign up. And put a reminder in your phone so you remember. And CalChat to keep you accountable.
Yeah.
Okay.
Oh, well. It is day to day. Faster.